You know, there's this whole world of communication that's so vital, so fundamental to our lives, that we almost never even think about it. It affects our health, the technology we use, pretty much everything. And today, we're going to pull back the curtain on it. We're talking about the hidden art of scientific translation.
So, let's start with a little riddle. What on earth could a medicine label, the kind you read when you have a headache, and the wild brain-bending world of quantum physics possibly have in common? They seem like they're from different universes, right?
Well, it turns out they are completely dependent on the very same thing. Skilled translators who can carry ideas across languages and cultures without anything getting broken along the way. Yeah, it's scientific translation. It's the invisible engine that drives global progress. And you've got to understand, this is so much more than just swapping out words. We're talking about a process that allows scientific discoveries to shape policy, fuel education, and help the public understand what's actually going on in the world. It's a super high-stakes part of science itself. I mean, think about it. In science, one tiny little mistake, one little bit of ambiguity, could lead to a catastrophic error. So the goal here isn't just to change the language. It's to perfectly preserve the original meaning, keep it incredibly precise, and make absolutely sure that it's understood.
So where do the problems start? Well, one of the biggest hurdles is what I like to call the terminology puzzle. Science just moves at lightning speed, right? It's constantly churning out new ideas and tech way faster than our languages can create words for them. And this really breaks it down for us. Translators are staring down the barrel of terms that just don't have a simple one-to-one equivalent in another language. They have to navigate this minefield of dense jargon, brand new words or neologisms, and sometimes the scientists themselves haven't even agreed on what to call a new thing yet. It's a constantly moving target.
And the way new terms get created is sometimes just wild. Get this, the physicist Murray Gell-Mann, he needed a name for a new particle he'd discovered. He said the sound quark was just kind of floating around in his head. Then, one day, he's reading this famously difficult novel, Finnegan's Wake by James Joyce, and boom, he sees the word quark. He just took it. And a cornerstone of modern physics was born from a piece of literature. Isn't that amazing?
So, imagine you're a translator. When a game-changing term like CRISPR comes along, you have a huge choice to make. Do you just borrow the original English word? Do you try a calc, which is like a super literal word-for-word translation? Or do you just paraphrase and explain the whole concept from scratch? Each path you take has massive consequences for how well people will understand it.
So that's the word puzzle. But then there's the people puzzle. The second huge challenge is figuring out who you're translating for. Writing for another scientist in a lab is worlds apart from writing for a politician or for you and me. It's this incredible tightrope walk between being totally accurate and actually being understood.
Exactly. If you're talking to a fellow researcher, sure, you can load it up with jargon and complex sentences. They'll get it. But if you give that same text to the public, forget it. It's just a wall of gibberish. So the translator has to be constantly adjusting the dials, changing the complexity without ever twisting the science. Okay, take a look at this. This is a perfect example of science being explained for everyone. It's breaking down photosynthesis. Notice how clear the language is, how direct the explanation is. The number one goal here is making sure someone who isn't a biologist can read this and say, okay, I get it.
And this quote, man, it just nails the whole challenge. The translator is a mediator of relevance. That's so good. They're constantly asking themselves, what is the most important thing for this specific reader to know? And then they have to balance that against being 100% faithful to the original text. It's a huge intellectual balancing act.
All right, so we've talked about the terminology puzzle and the audience tightrope. Tough stuff. So how do translators actually pull it off? Well, they don't just wing it. They come armed with a seriously sophisticated toolkit of strategies and ideas. Let's break down that toolkit. First up, and this is a big one, domain knowledge. You just can't translate what you don't deeply understand. Then there's terminology management. This is where they use glossaries and databases to make sure every term is used the same way every time. After that, they do audience profiling to perfectly tailor the text. And finally, peer review. They get another expert to double-check their work. No room for error.
Now, there's this really cool idea that guides a lot of this work. It's called Scopus theory. Scopus is just Greek for purpose. And the theory basically says the most important thing to think about is the purpose of the final translation. So before a translator even touches a single word, they ask, what is this for? Who is it for? And the answer to that question shapes every single decision they make from there on out.
And this whole idea of purpose leads to another powerful strategy, localization. This is where things get really interesting, because it goes way beyond just words. It means adapting the entire package to a local context. You're changing miles to kilometers, swapping out cultural examples that wouldn't make sense. You might even work with people in the community to invent new terms together, just to make sure the science truly connects.
So when you put it all together, all these strategies, all these theories, it really all points to one thing. The human translator is this essential bridge. They're the ones connecting scientists to other scientists, and maybe even more importantly, connecting science to the rest of society.
Of course, everyone asks, well, what about AI? Can a machine do this? And yeah, machine translation is an amazing tool. It's fast, it's efficient, but it really struggles with the tricky stuff we've been talking about. Context, cultural details, brand new words. That's why the best approach today is a team effort. The machine does the heavy lifting, but a human expert is always there to make those final, critical calls.
And listen to this, because it really captures their active role. Translators aren't just passing along messages. They're in a position to build bridges, for example, between a research lab that makes a discovery and a doctor's office that needs to use it. They help create this feedback loop that actually pushes science forward. So what's the bottom line here? First, scientific translation is basically complex problem solving. It's this delicate dance between cracking the terminology code and meeting the needs of a specific audience. To do it, translators use a whole toolkit of sophisticated strategies, and at the end of the day, they are absolutely essential for spreading knowledge around the globe.
And let's be real, this isn't just an academic exercise. This matters, right now, more than ever. We're living in a world that is facing massive, global challenges. Pandemics, climate change, our ability to share and act on scientific facts across borders that can literally be the difference between life and death.
Which leaves us with one last big question to think about. As science gets more and more complex, more specialized, this challenge is only going to get bigger. So how do we make sure that all this vital knowledge keeps building bridges and never, ever gets lost in translation?